Good morning and welcome once again to Online Python. I'm coming to you from my living room bright and early before the sun is even up. So today we're going to talk about object-oriented programming. This is a major topic in computer science, and as you may know, it's quite involved. So we're not going to have the opportunity to talk about all aspects of it, but my hope is that you'll at least get a taste for what object-oriented programming is and have a primer for what it is you might need to know if you do go on in programming, and so you'll have some idea as to how to work with this. So let's go on over to the PowerPoint. Screen. All right. Switching over to my screen any second now. All right, oh, there we go. Okay, and let me just put up the PowerPoints here. Slideshow. Ta-da! Okay, there we go. So this will be for our April 14th, 2020 lecture. And I will mention this will be the final lecture content for the second exam of the semester, which will be some kind of a take-home exam. And as we actually get closer to the date and as I have a little more time to actually work on making it, I will give you some more details as to what exactly the exam will entail. So here we have our course calendar, and this lecture represents this section right here. Classes, objects, and methods. This does in fact cover 3 chapters in your reading, so certainly you can feel free to skim those and maybe not read them in as much detail as you normally would, because I do understand that's a lot more material than we typically have. I'd note that we do have a break next week in the materials, so we do have some time to review for the exam. Usually what we do during this week is actually take some time to work a practice. So we would have done a practice exam during the lecture time and had a question and answer period. So of course that, as everything else this semester, is now moving to online, and we would have had the project workshop next week, and so that will turn into some time for us to just confer about the progress of your project. We won't be having the project presentations as we would have, because obviously we're not going to be meeting in the lab for doing that. So basically we have a lot of time when we can confer about your project. So do make sure you let me know how your project is going, and let me know if there's any sorts of things that I can be helping you with that. Our final lecture will be called Applications of Programming. This is a lecture that I really like to give because it just gives you an overview of what it is you can do now that you've learned how to program. And so I'll be talking to you about some of the things we visited in the very first lecture during the introduction. That is, how does this fit in with the bigger picture? Now that you've done this, maybe you weren't too sure if you were going to enjoy it, but maybe you've realized that you love programming and you want to take more, which we hope is your sentiment towards programming. So think about, how could you use this towards a certificate program, towards a minor or major, and other things like that. And also, what job opportunities could you possibly have now that you have all these wonderful programming skills? As I'm sure you're aware, the final project will be due, and it will be due Wednesday, May 13th, 5 p.m. Eastern Standard Time. I am going to stick really strictly to that deadline, and the reason for that is that I do have a very short turnaround time between when I receive your projects and when I need to turn in your final grades to the registrar's office. So it is really imperative that you just turn in whatever you have and turn it in at that time. So I don't accept late projects for that reason. You've had all semester to work on them, so please do get in whatever you have completed at that point. Okay, so a bird's eye view of what we're going to talk about today. So we're going to talk about motivation for object-oriented programming. In fact, object-oriented programming doesn't add anything new to what you already know how to do in terms of what it is you can actually accomplish. We haven't used objects really, well, you've used some implicitly, but we haven't written code explicitly in object-oriented programming all along, so why do we even need to do this? There are arguments for and against using object-oriented programming, but much of the world does use it, and so I think it's important to understand why that is the case. We'll also talk about defining a class, which is basically fitting into how we make a blueprint for an object. We'll talk about how all these pieces fit together, adding attributes, that is making things variables that pertain to your object. Methods, so methods are simply just a function put inside of an object. We'll talk about why that happens. And then also Python has built-in special methods, or sometimes they're called the magic methods, that do special things that you may not anticipate, but also can be extremely useful. So that's what we'll talk about today in our overview of object-oriented programming. So what is object-oriented programming anyways? So object-oriented programming is a way of organizing your programs. Programs are made up of classes and function definitions, and most of the computation is expressed in terms of operations on objects. That's how object-oriented programming would be arranged. Each object definition corresponds to some object or concept in the real world. So for example, as you're thinking about your projects, maybe an object could be a ball moving on a turtle screen. So you might have multiple balls in your game. And so each of them could be defined as an object. And the functions that operate on that object correspond to the ways real-world objects interact. So part of why we do object-oriented programming is to help arrange the items so that we can think about what it is that we would think of as the attributes, what we would think of as the variables that we need to do, to try to think about how could we make something move or walk or animate or do whatever it is that it needs to do, thinking about it not necessarily in terms of writing functions, which is how we've been talking about things so far, but if we could move it into a more intuitive kind of a setup so that the inputs that are required would be what we call in chemistry observables, just things that you would actually be able to measure or know what they are, instead of trying to think about other things that you may not necessarily know off the top of your head, but could be calculated by the computer. So if the computer can calculate those things and we always need to calculate them, why bother for us to calculate them? Let's let the computer do it. And that's kind of the thinking behind object-oriented programming. So what is an object? In Python, all values are in fact actually objects. So you may not have known that so far, but as a matter of fact, most of the things we've been working with in Python all along are in fact objects. There are different objects which each have a type. So we've used some objects and the type can have associated methods. So we've actually seen this already, for example, strings. So strings is a kind of an object in Python, and when you do type of a string, it will tell you str for string, it's type string. And there are associated methods, so there's certain things you can do with strings. So for example, you can do is alpha, you could do dot upper, you can do dot lower, you can ask is alpha, things like that. We've also seen some for lists, and we've also seen methods that are used with dictionaries. So classes are examples of objects, right? So we have these different classes, and why should we be stuck with only the ones that the authors of Python already wrote? So maybe we want to make our own, and so Python programming allows us to create our own classes, which are blueprints for objects. Specific examples of objects are called instances, and so then we can make those particular instances, which is basically, for example, making a separate turtle to walk around on your canvas. So why stop at just one? You could have multiple turtles on your canvas. And so each of those would be an example of an instance. So a retrospective look, in fact, you've been doing object-oriented programming for quite some time. Like I said, you just may not be aware of it. So there are built-in methods which are functions associated with the class. So for example, we've seen a number of these. I have a bunch of list methods down here: insert, append, extend, pop, and remove. You remember we had all of those. We also have some that are associated with the strings, as we just mentioned. And here's even some more examples from the strings. So we had methods for strings, lists, dictionaries, and many more. And there are, of course, many other ones. So those are the examples of the ones that Python already has that we've just been using. But the point is, you don't have to be stuck with only the ones that Python wrote. So suppose you wanted to have your own. Can you make one? Well, that's what we're going to learn how to do today. So an example of a familiar object. Let's just go back and consider strings as objects. So Bird equals cardinal. This is an example of a variable assignment where the variable bird is assigned to the string called cardinal. So strings are Python objects. They have the type of str for string. There are certain things you can do with strings. So the idea is, based on what kind of an object it is, there's going to be a collection of things you can do with them. So how did they get to have that collection of things that you can do with them? So for example, you can concatenate them, but you can't do some things like divide them. So why is that true? Well, it's because somebody wrote some code, but the things that they can do and some other things like division of strings, which would be a ridiculous thing, isn't defined. And so nobody wrote the code to do it. And that's why we can concatenate them, but we can't divide them. They have associated functions which are called methods. So basically just a function that pertains to an object is called a method. And we're going to learn some more about how to actually do that today. So for example, here is a method. So here is the variable name of a string, and being of type string, it's able to access the dot upper, which is going to be a function that is associated with the type of this variable here, which is string. So this says a couple of things. It says here's the variable that resolves to string. So because the type is string, it's an object and it's an example of a string. And strings have some things associated with them. One of them is upper. And so it will work. And upper we can recognize as being sort of like a function because it has these parentheses here. So more specifically, when it's a function associated with a particular object, it's called a method. What exactly that means will become apparent as we look at some of the code to actually write one. And we'll actually work on having a regular function and then converting that function into a method today. So what is all of this good for? I mean, it sounds kind of complicated. Maybe we should just not even bother with it. Why do we need to do that? Like I said, it does not add any new functionality to what we can already do. However, what it does do is it does offer more concise syntax in the part of your code that you're actually writing. So imagine if to do dot upper, you had to in fact actually write out every single time a function to parse every letter and then actually convert that letter from the lowercase to the uppercase, right? So you need to do like some sort of ASCII mapping of the characters or something. So sure, you could do it, but can you imagine how long your code would be? Think of how nice and concise it is that once you have a dot upper function, you don't have to keep writing it. It just already exists. And every time you have a string, you should always be able to put it into uppercase, right? So instead of having to do that every single time, you just have it and then it's good to use. And that's kind of the idea behind it. Because you're able to then move out all the details, that low level of the code where you're saying, okay, here's the loop and here's what we have to do. Instead, you can think about the problem in a more high level kind of a view, a little bit more abstractly, so that you're thinking about more the big picture of the code rather than focusing on some of these more minute details about how do I write something to convert each letter to uppercase, right? Once you do it, don't reinvent the wheel, just use it. And so we might have situations like that with kinds of objects that we would be working with that Python could not preempt, such as maybe you have a particular data structure. So for example, maybe I want to represent an atom, and atoms can make bonds. So I maybe want to have, objects with atoms that have the number of bonds, right? So that's not useful to everybody, but I should be able to make it if I want to. That's sort of how that works. So classes are just user-defined objects. You could make your own. So let us consider this idea of doing a photocopy, okay? So it doesn't work exactly because there are a few things that are a little bit different, but it gets the general idea across. So imagine that we had a form for points, okay? This would be really simple. So what do points have? Points have an X and they have a Y coordinate and you can graph them. So if we were going to, say, for example, interview a bunch of points, so let's imagine some points came walking by and we wanted to interview those points to find out what their name was, so like some variable name, and what their coordinates were. So we might in fact actually have quite a few points that we needed to get the information about. So in order to do that, we might consider having a clipboard, and we could write out form for points, and we could write down the name and X and Y every single time. But we would quickly realize that if we had lots of points to interview, that maybe instead what we'd rather do is just recognize the fact that all points have a name and an X and a Y coordinate, and we could run into the handy photocopier. Of course, if it's not broken, which ours is at the moment, we'd just run into the photocopy machine, and maybe we could just run off a bunch of forms that all look like this. Right, so we say, okay, great. So I know we're going to need to fill out one of these for each of you guys. So let's just photocopy the form, because it's always going to need the same fields in here. So wouldn't that make life easier? So then what you could do is then you would go in and say, okay, let's go interview the point. So you say, okay, here's an instance, say, hello, Mr. Point. What's your name? Oh, you are point 1. Okay, we'll write down your name here. Okay, do you have an X value? Oh, it's 2, and a Y value, oh, okay, it's 4. Great, and then we write it down and we go to the next one. Okay, and I say, hello, hello, little point there, do you have a name? Oh, it's point 2, great, and 1, 2, terrific. And so maybe we have lots of points. So here's a whole bunch of instances of points. So this form right here, this is the blueprint for all these other forms. So the idea is that we would be able to think up what it is that we need to put on the form, and then we could copy it. Those instances are going to be your objects. And this form right here is the class. It's the blueprint, the master copy, the blank form for all the other points. And then what we're going to do is we're going to have instances of specific points. So this is the instantiation of each of the points, the instance of that point, which has a particular name and some attributes. That is, the value of 2 and 4 is associated with it. And so that will be true for all the points that we need to collect and get information about. So that's kind of how it works. So a class is going to be a blueprint for making objects, just like the master photocopying sheet, that blank one, is a master for making all the instances of the points. It groups the variables needed for an object into a single entity. So every point has an X and has a Y. So those are now going to be associated with that point, because all points are going to have it. So we always need to get that information. It allows functions required to operate on the variables to be grouped. So we haven't seen how to do functions yet, but shortly we're going to do the distance function, which is right on the other side of this slide. And it provides a way of handling many similar instances, of similar objects. And so how could we consider a point as an object? All right, so the old way of making a point to make the distance might be something like this. So maybe what you would do is you would write def distance. So you'd write a function, and we need a point A and point B as some inputs, right? So we're going to have a list, and you might have some information in this list that contains the XY coordinates, and we could have it have 4 fields in your list, or 4 entries in your list. So arrange such that the first 2 are the X and Y of the first point, and the second one are going to be the X and Y coordinates of the second point. And our function should return the distance between the 2 points. Pythagorean theorem. And just to remind you, a squared plus b squared equals c squared. That is the Pythagorean theorem. And to solve that, c is going to be equal to the square root of a squared plus b squared, and that will give us the distance. So having that information in mind, what we're going to do is we're going to import math, because we might want to do some math things like absolute value. So here we go. We're going to have a is equal to the absolute value of the difference of the point A of 0 minus point B of 0. Okay, so what we're going to do, yes, so this is assuming that it's actually it could be arranged as a list of lists. And then what we're going to do is then we're going to subtract. Right, so basically we're subtracting the y's and we're subtracting the x's. Here we're going to do the square root to get the, so it's the square root of the squares of the distances, which is what we've done here. This is just working up the Pythagorean theorem. and then we're going to return C, which is going to be that distance. So here we have point 1 being 1, 2, and point 2 being 2, 4. Just to be clear, how this is going to work is this is being read in, so point 1 will be point A, right? So this will be a list with 2 values, and then this will be a list with another 2 values in it, which is why the subscripts for the Y's and the X's are both matching 0 and 1. So it would not, in fact, be a list of 4 items, as I said before. And so then what we're going to do is we're going to print the distance of point 1 and point 2. So we will run this function, and then we will get our distance out. And that would be the old way of making a point. Do you agree? So all of you should be able to write something like this already at this point, not object-oriented programming. So let's take a look at how we might do this a little bit better. So let's design a class for a point. So what are the properties of a point? So the needed variables. We kind of already talked about this when we looked at the form before. So we're going to need an x coordinate and a y coordinate. And some of the things we want to do with points, we want to compute the distance between this point and another point. So this is getting into how we might be developing methods. So we're thinking ahead of time, what are the things we'd want to do with it? So when somebody wrote the methods for strings, they said, okay, if I have a string, what are some of the things I'd want to do with a string? Well, maybe I'd want to know whether it was alphabetic or not. Maybe I wanted to know if it was a digit. Maybe I want to convert it to uppercase. Well, what do we want to do with points? Well, maybe we want to compute the distance between this point and some other point. Maybe we want to compute the slope, something like that. Could there be other things? Sure. So what we're going to do is we're going to define a new class. So we're going to declare this will be a new class using the keyword class. We need to provide a name for the new class. And so, as you might expect, it's going to pretty much follow the same convention that we've used for defining functions and other variables. Can't start with numbers, don't use special characters, you know the drill. By convention, user-defined classes begin with a capital letter. So this is not enforced by Python, but it's a convention that people use, and it's helpful to identify it as being a class. So the type will be an object. So here we go. Syntax looks like class, and then you give the name of your class, and you're going to use these empty parentheses and a colon, and then whatever you're going to put inside. So hold that thought on what will go in the body. We're going to see how to do that in a moment. But first of all, let's start off by being able to make one. So something that you might want to put inside is this init function, okay, which will in fact be a method. So you have to do it exactly like this. You cannot name it something else. I'll also point out that this is double underscores, which is a little bit difficult to see because it looks like there's only one dash on either side. But so there's in fact 4 dashes, 2 here and 2 over on the other side. So consider all the variables that you're going to need for a particular instance of each point. So we already said, how about x and y? So we're going to set up the form for these variables using init. So it means initialization. It's going to say, let there be an x, let there be a y. So all classes generally should just have a function called init because they're almost certainly going to have variables. I don't know how you would have a class that didn't have any variables, so you really need to have some variables. And you need to initialize those variables because they need to exist and have some value. So init is going to take care of that. Init is just automatically executed when a particular object is being created as an instance of the class. The self variable, which is a really curious thing, appears as the first variable. What is self? So self is a variable that means pertains to this object. So since we could have multiple instances of an object, we are always going to have this self variable to say that it's the x that belongs to this variable, the y that belongs to this class. So that's why we're going to have self. We'll talk about it a little bit more because it is a kind of an odd concept to get. It's used to indicate that the variable will pertain to its own instance and not some other instance of the class. That will become apparent when we make 2 points. So when we have 2 points in existence, we may be able to calculate, say, for example, the distance between them. So we'll have this point and its own x, y, and another point, which also is an example of the object that has its own x and y values. And so that's why we need the self. The variable values passed to init are going to be used to set up the variable values that pertain to a particular instance of the object. So when you start or create the instance of an object, you will be giving information to init to get it started. So let's just take a look at what the syntax looks like. So again, we're going to have the definition of the class, which we've already seen. And now inside that class, which is why it's indented like this, we're going to have this initialization. So we're going to def init. Now you're not allowed to call it anything else. So unlike other functions that you've used before, you can't do that. And the reason is because it has these special properties that it runs by itself. So if you call it something else, Python won't do that with it. So here's what you need to do. You always put self first, and then you're going to have whatever variables you need. So what this will be like is whatever variables you would have as your input parameters for a function. So basically, all these kinds of functions all have self, and then they have whatever else you need in order to run the function. That's how you should think about it, except it's a method because, as you see, it's not defined in main, it's defined inside the class. So then what we're going to do is then we're going to actually go ahead and initialize those attributes. So the way that it works is we're going to do this self dot, because this means that this particular instance, whichever one we're going to make in the future, is going to have some attribute 1, which needs to have the value that we specified. All of this sounds a little bit abstract at the moment. So we could actually talk about something that's a little bit more concrete here. So here's an example of class point. So we've already shown how to do that, right? We define a class. Notice this is in capital, not because we have to, but because it's the convention. Now we're going to define exactly the function in it, not spelled any other way, and with 2 underscores on either side. We've selected self because we want these things that we're going to initialize to pertain to a specific examples of this that we'll create. And the inputs will be an X and a Y. Now, what this does is this actually sets up those X and Y. So this says, for a particular point, it will have an X value that takes the value of this parameter X, this input parameter. So this X means this X that is provided up here, and this Y means it will take whatever value is given for this input parameter Y right here. And then it will set it up and assign it to this particular point. So if we reuse this class point to make, for example, a second, third, fourth, 100th point, that each of them will have their own X and Y coordinates that are distinct. And that's why we need to have self. So that brings us to instantiation. So kind of sounds like instance. So what an instance means is it means a particular point. One of the interviewees that we saw when we made our blueprints to go and interview points. So let's pull one out of our sheets of paper. Oh, look, it's point 2. It has the X of 1 and Y of 2. So that's a particular instance. Instantiation refers to creating an instance or a particular example of the class. So we see that this point here is an example of class point, which we've now seen how to define. The instance is an object, which is an instance of the class that created it. Filling out the form for point 2 is an instance of the class point. So what we need to do when we're going to make it, instantiate it. So that means like, let there be a point. So when we do that instantiation, we need to provide the input for the init method so that it will have the information to fill out the X and Y. So when that instance is being created, we're going to need to provide that information, similar to providing the input for a function. Note that self does not require input information, so the values are going to be assigned to the next variables in order. So remember, we have self in there, and usually when we would be putting information into the function, they would line up. But because self is extra and doesn't take any values, it doesn't take any input, we're not going to match any values up to self. So if you have self X and Y, That's three different aspects. When we put in the input that we're actually going to add, we only need to add two things because self doesn't get any information and automatically doesn't get it. So here's how it's going to work. The syntax is you're going to name your object, your particular instance. So a specific point equals, now you need to tell which class you want to use, which is point, and then you're going to give the arguments, that is the values that need to be filled in. The number of arguments needs to match however many things are listed inside of, inside of your init function. So if you had two input parameters plus self, then self doesn't get one, so you'll need two inputs. So there'll be two arguments here. So let's take a look at how this actually works out. Here's an instantiation example. So let's create a particular point called P1 such that P1 is equal to 2, 3. And so this is just our regular math notation, X, Y. The class point is being called. And so then the init function in the class point is going to be executed because that's what happens when you have init there. The first argument 2, here's our 2 from here, is assigned to the first variable after self, which is X. So X equals 2. All right, so here we are. Let's just take a look at what's happened so far. So here is our variable name. So it's going to be called, well, so this will be a particular point called P1. And what this says is P1 is going to be a particular instance of the class point. So this calls class point. So sort of like how we called functions, this is like a class call. But class calls do something a little different. They are going to send the information into init if it exists, which it should. So now what happens is this information 2, 3 goes up and goes into the init function. So there's two pieces of information, 2 and 3, which match up to X and Y because self doesn't get any. So it matches, that's good. There's two inputs, there's two variables plus self. Now, what's going to happen next is this information is going to get assigned to these variables. So self.x is going to take the value of x, which got sent up, which is 2, and self.y is going to be equal to y, which was sent up as 3. So that's how the particular point P1 is now going to have attributes x and y, which pertain to point 1 and will not be associated with any other points that we might make. All right, and so here's the input parameters, right? X is 2 and Y is 3. And these are the object associated attributes. So they became attributes by going into here and being assigned down here. So it went from input parameter into object associated attributes. So suppose you wanted to access the value of the attributes. Basically, suppose you defined a variable and you wanted to see it. Well, it's a little different than a regular variable, so now we're going to take a look at how we might do that. So the way you're going to get out the attribute is we're going to need to use the name of your object, and then you're going to need to use the attribute, right? So we can't just use x anymore because suppose there's more than one point, we're going to have more than one x. And so if we hadn't done object-oriented programming, we would have to have a different name for every single one. But why not just have it as an attribute? And so this makes it so much simpler. So what you do is you just say which object you wanted and which attribute you wanted. So if we wanted to know what's the value of x, you say Python p1.x, and it will return 2, because this says 0.1 and the attribute called x. And since we defined that and we initialize that, then it will know what it is and return it back. And the same thing for y. So suppose we wanted to do some calculations using the attributes of P1. So you could do any kind of calculation. I'm just going to pick up the idea of doing the absolute value of the difference of them. Not that that's particularly meaningful, but it's something that you could calculate. So we import math and then we do the absolute value. So P1.x will pull out the value of x, which is 2, and P1.y, which is 3. So 2 minus 3 should be -1, and the absolute value of that is 1. So we get that. And so also we could make up some other crazy functions that you want to calculate. So I have no idea why you'd want to have the sine plus the cosine, but maybe you did, and that's how you would do it. So you can basically access the values of the attributes and do whatever you need to do with them. So that might bring to mind a question about mutability. So after they're defined, are we stuck with it? Luckily, the answer is no. Mutability is going to apply. So that means we're going to be able to change and update the values, which is incredibly useful. So the values of the attribute can be mutated. We can use variable assignment with the dot notation to update a value. This is very similar to if we had defined a regular value and we just wanted to update it. So how would you do that? So suppose you had x equals 5 and now you want it to be 6. You just do x equals 6. But now if we ask for a value of x, we wouldn't know to which point does it belong. So the way that we call it is we're going to just say which object it was. So we just go my object dot attribute equals new value. So here we're going to have p1.x. This says what's the current value of p1? It's 2. Now we're going to do a variable assignment. p1.x equals 5. Mutate the value and say Python, what's the value of p1.x? And now it says 5, which updates it. So that shows you that the variable table has updated, which is exactly what we would hope it would do. Suppose you want to print it. Well, that's something reasonable and you might want to do. Various aspects of the class, objects, and object attributes can be printed. Information from printing the class will include the name of the class and where the class is defined, such as in the main. So here's the syntax. Suppose you want to print the class, so you would do print and my class. Notice the parentheses, and then of course you fill in the name of your class. But you could also print an object, which is an instance of the class, so you could do print my object. So this is printing the blueprint, and this is printing a particular object or instance. If you wanted to print an attribute, then you would do print my object dot attribute. Oh, and there should be a closed parentheses here that somehow got lost. So you'll need to do these 3 different print statements depending on which of the aspects you wish to see. So here's some printing examples. So if we print the class itself, print point, we're going to get that it's a class and it's going to tell you that it's in main because that class is defined in main. If we do print p1, this is an object which is an instance of the class point. We would get main because that's where it exists, point object, and then this is giving information about where it's stored on the disk. So do not be concerned with interpreting this, but just know that it's pointing to a particular memory location almost on the hard disk. So suppose we wanted to print out the attribute information. So here we have print, and then we're going to print out p1.x, which is 2, and p1.y, which is 3. So the next thing we need to talk about then is how could we actually make our own method? So we've talked about the init method, but it's kind of boring because we're kind of stuck with what Python already has for that. I mean, it is very useful, but suppose you wanted to do something else yourself. Maybe you wanted to, I don't know, inventory some cars or compute some distances, translate some things in space, whatever it is you want to do, you may want to be able to write your own. So we could have a function written outside that accesses each of those, but if you always need to have that attribute for a particular type, then the better thing to do is to convert it into a method. Essentially what you need to do in order to make something a method is basically put the function inside the class with a few other things, because we're going to need to use self with this as well to say that we should use values from the object itself. So let's consider the task of writing a function to compute the distance. So I've already seen the Pythagorean theorem. I just put a refresher up here for you again, just to make sure, you know, everybody's on page with how to compute this, just in case your math got a little rusty, and just to keep me honest and make sure I'm, you know, doing the formula correctly. So let's consider writing a function that takes 2 points as a list as input and returns the distance between them. So if we want to use the points 2, 2, and 4, -2, we could do that to test the code. So what I've done is I've pulled this nice example that is drawing up a triangle on the XY plane, and we can see that there's a hypotenuse here, and the distance of this is going to be equal to the square root of 2 squared plus 4 squared, which you can verify by you doing the Pythagorean theorem by hand if you wish. So that'll be the square root of 20, which is about 4.47. So if our method is working, we'd better get the same number. So let's make sure. Okay, recall the distance formula, again, is derived from the Pythagorean theorem. And so we can use this solution in order to write that function. So in order to get started, what you might do is pause the video and take a moment to go ahead and try to write that function looking at the information that's available on this slide. All right, welcome back. I hope you've had a few moments to try doing the distance function. Let's just take a look at a possible solution for that. All right, so this is what it's going to look like, or anyways, this is my solution to that. Yours might be a little bit different. So I've imported math and I defined a function called distance function, and it takes 0.1 and 0.2 as input. So this will be a list of ints, right? So we have a list of int, comma, int, and again, another list of int, comma, int. So that's for this point and for 0.2. And the answer, which will be the distance between them, will be returned as a float. Preconditions are the list represents the XY points. Input can also handle floats instead of ints, so that should be fine. It could be either a float or int. Returns the distance between 0.1 and 0.2. So here we go. A is equal to 0.2 of 0. That's the x coordinate minus 0.10. So that's the x coordinate of that. So we're going to take the difference in the x's. Here for B, we're going to take the differences in the y's. Note that you need to do 0.2 minus, so it doesn't really matter which order you take this difference in, but you have to do it the same way for each of them or else you'll have a sign problem. So you can do 0.2 minus 0.1, or you may have done 0.1 minus 0.2, but whichever way you did it, you need to do it the same way for both A and B. And C then is going to be the square root of A squared plus B squared, which is why we needed to import math. And then we're going to return C, which is the length of the hypotenuse. Yeah, don't be confused by this point C here. The letters don't exactly correspond to the diagram because the letters are representing the sides and here they're representing the points. So what we're going to do then is we're going to have a function call here, and this is going to take the distance function of these points. So this is what it would look like. We said we were going to send them up as a list. So here is each of my points represented as a list and going into the distance function. So when we run this, we get out the distance function returns 4.47, blah, 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 which is terrific. Ta-da! It matches what the correct distance is supposed to be, which is always a really good check. So the object as a collection of attributes, yeah, let me just put this, and methods. So an object, you could imagine, is going to have a series of variables associated with it, which are going to be the attributes, and a series of methods. That is, things you're going to want to do with it. So for example, it might be init, and it could also be the distance function or any other function that you wanted to write. So calculating the distance to a point object is a common task that we would like to automate, which is why we're going to consider putting into a method. We're going to need the point itself and the point to which the distance is to be computed, and then we're going to need to use the distance function. So wouldn't it be convenient to have all these related items packaged into just one object? So if you're going to have to do it every single time, why write it out every time? Why worry about it? If you just put it in the object, then it's done. So that's a really good way to organize the code. Again, object-oriented programming doesn't add any new functionality. What it does is it adds better organization to your code. So we can move the distance function inside the class definition to make it part of the point object. And once that happens, it will, voila, become a method. So how are we going to define a method? A method is a function defined inside a class. Defined the same way a function is defined with a few minor changes. First of all, it's going to be located inside the class instead of located out in the main. And the other thing is the first parameter is going to be self. Reason being, we need to say this method pertains to a particular instance of this class. So obtaining the value of an attribute variable is achieved again using the self.attribute notation rather than passing it as an input parameter. So we saw that when we set up a point and set up some certain values for it. So here we go. class and then my class, then you're going to have your init function here, and then you're going to have whatever else you might have. And here's an example of putting in your own method. So you're going to have the name of your method, and then you're going to have self, just like we had in init, and whatever input parameters are needed. Then you're going to have your signature and description here as usual, and then whatever you need to do. And you might do some things with an attribute in the method itself, like calculate something. So let's do a comparison between the function versus the method version. Okay, so here is our function version that we wrote earlier. So each point is an input parameter of the function here. So here it is, here's 2 points that are input parameters, and this is the function which is just defined out in main. Now, in the method version, it's a little bit different. So the self parameter is the first input parameter. So here, let's just compare. Here is the definition of the distance in the method version. We see that we need to also include self, whereas we don't have that in just a regular function. But we also have some values here, x2 and y2, which is similar to having 0.1 and 0.2. Of course, these are just variable names, so what you call them is inconsequential. You can call them whatever you want, except self, which has to be called exactly only self. One point is the point itself, and the other point is some other user-specified point. Okay, so that's an interesting thing. So notice here that if we're going to use the distance method, what it's going to do is it's going to take the distance between 2 points. Okay, so notice that what's happening here is this x2, y2, right, is going to be some other point that's not this point. But what we're having here is that its own x and y value don't have to be looked up. So it's kind of like this. If you say, you know, how's Bob doing today? You know, well, which Bob do we mean? So, you know, if you have a classmate Bob who always sits next to you, and I say, no, oh, how's Bob today? I noticed he's not in class. Which Bob do you think I mean? Do you think I mean, you know, Bob Vila, or do you think I mean, you know, some other Bob that you never met, or do you think I'm talking about the Bob that's, you know, the one that sits next to you all the time? It's, of course, the familiar one, the one that sits next to you. And so that's kind of the idea with the method. So if you're talking about a particular instance of an object, and we're saying, well, I want the value of x, right? We're going to do self.x. So I'm talking about my x value, that particular object attribute. So that's why we have the self in here. So we're going to have self.x and self.y because we're talking about its own x and y values. It's sort of just like come with it, just like how you would have common knowledge about your best friend Bob. Okay? And then the other one will have an x and y value that are from some other point. That other point could be another instance of your class. And in fact, that's how you should define it. But what you're going to do is you're going to have those be other values. So those will be just x2 and y2, which will not be accessed using self because it's going to pertain to the other point. So what we're going to do now is we're going to do a equals x2 minus self.x and y2 minus self.y. Whereas here we're just doing the difference between the points explicitly, whereas this one is going to say whichever the current point is, that's the one that I just defined is what the self.x and self.y is, and we only need to pass in the information of the other point. And so then we're going to compute the square root off of a and b just like we did above, and then return c, which is no different than the previous one. So suppose you want to call a method on a specific instance. How would you do it? You'd use the name of the object to specify which instance of the class you wish to work with. You would specify the name of the method you wish to run. The class that was used to define the object must contain the method. So if you call something that doesn't exist, it's like an undefined variable, it's not going to work. For example, you cannot run a list method on a string. Doesn't make sense. So you have to pick something that's defined and that applies to what it is you're working with. Provide the arguments required for assignment for the input parameters of the method. Self is always a parameter, the method, but no value is required just like we talked about before, and the arguments match in order to the parameters except that self is skipped. So it would be like this, my object dot my method, and then you provide the arguments that are going to match to the input variables except self. So that might become a little bit more clear if we actually just take a look at an example, which there's one shown here. So example, calling distance method for point 1. So point 1 here is equal to point 2 comma 2. We create a point object. Distance equals point 1 dot dist method of 4 comma negative 2. So this calls the distance method. Notice that we're only giving one point value. This is the value of the quote other point. Its own point, having 2 comma 2, is already known because it's part of that object instance already. So then it's able to compute the distance between the point 1 and 4 negative 2, and then it will report back the distance. And here is distance calculated, point 1 dot distance method of 4 negative 2. So here it is over here just for our reference. And so when this happens, then it's going to compute the distance between them. And again, that comes out to 4.47 as we saw before. So this is how you would move it into being a method and how you would be able to call that and actually calculate the distance. So here is an exercise for you to try. Let's create multiple point objects and compute the distances between them. So create the following 3-point objects from the class point. So here are some 3 points, point A, B, and C. So use the distance method, calculate the distance between point A and the coordinates 0, 4, and print it to the screen. Then using the distance method, calculate the distance between point A and point B. There's 2 different ways to do this, because either you could go having the current point be point A and point B be the other point, or point B could be the point and point A could be the other point. So think about which way you want to do it, and you could in fact challenge yourself to do it both ways if you really want something harder to do. These 3 points then trace out a right triangle. You could use the distance method to compute the length of the hypotenuse of the triangle and print it to the screen. All right, so why don't you go ahead and see if you are able to do that. I would recommend you actually do this one on your computer. I know oftentimes I recommend you do it on paper if you can. But this one, I think, would probably be a good idea to try it on your computer. You're going to need to have the definition of point, of course, which I'll put up here for your reference. So why don't you go ahead and try that, and then after you've attempted that, then let us rejoin back and continue on. All right, so welcome back. I hope you had a chance to try out writing your point objects and computing the distance between them. So here is my solution on how this could be done. So of course, this part over here with the import and the definition of the class needs to be in my script, and we're just going to assume this is at the top of the script. I just didn't have enough space to show it all in line here. So here I'm creating my points, which you know how to do. Point A, point B, and point C are each examples of the class point, and we're going to need to pass up that information of their X, Y coordinates, which I suggested values for in the question. So then we're going to calculate the distance between point A and 0, 4. So this is an example of doing it where the other point is exactly specified by its coordinates. So here we're going to do distance to point A to coordinates 0, 4, right? And here we're going to do a call to that method, point A. So this says use the information from point A, and now we're going to use the distance method. So this is an example of a point, so that's how it knows to go into point, and then it's going to say, oh, is there a distance method? Oh, yep, there it is. Okay, we're good. And the input for this is going to be, oh yes, self doesn't need anything but X and Y. Do I have an X and Y being sent up? Oh, yep, right here, 0 and 4. So this is going to send that information, and just like a regular function, it's going to run through the function and calculate up, and it will return back the C, which is the distance between those. Okay, the next thing we're going to do is calculate the distance between point A and point B. Now notice that point B has the coordinates 0, 4, so the distance had better be the same because it's in fact the same point. It's just that now instead of treating it as the input coordinates 0, 4, now we're going to treat them a little bit differently. We're going to treat them as another point object. So let's see what that would look like. So here we're going to print out distance of point A to point B equals, so it's going to start out the same. So this is from the reference of point A, right? So point A dot distance method. And then here we're going to, instead of giving the 0 and 4 explicitly, we're going to call those attributes. So this calls the attribute X from point B, and this calls the Y attribute also from point B. And so it should be the same. Now, I mentioned that you could do this in another way, and so this could also be solved by saying point B is the current point and point A is the other point. So what you would do to calculate it that way is you would do point B dot distance method, right? So what this says is, again, we're going to use the same class information, but the current point is point B, a particular instance of the class point, which so happens to be different than point A. This says we're using the distance method again, just as we did before. And now what we're going to do is we're going to have point A dot X, right? So now A becomes the other point. So we do point A dot X, that is the X value of point A, and the Y value of point A. So those will be plugged in as these values over here. So what happens is the numbers swap places, right? So the self dot X and self dot Y started out being for point A when we called it using point A, but when we called it using point B, these self dot X and self dot Y became these coordinates. So we just swapped the places. So to calculate the hypotenuse of the triangle, we should recognize the fact that it's simply going to be just taking the distance between two different positions. So it's going to be the distance between point B and point C. So here's an example of how that could be done. This is using point B as the point of interest, and point C is the other point. You could also have done this using point C to point B, just as you can swap these two, that would give you the same answer. All right, so that brings us then to special methods. So what is a special method and why are they so special? Special methods are methods with specific names that are going to perform a particular kind of a task. They're more or less predefined in Python. What the methods do is already predefined, although they are customizable for the user-defined class. So init is an example of a special method, which we've already seen, and it has a special property that is always run when an instance of the class is created as an object. So the fact that init always runs is part of what was included in the original Python code when Python was created. And it's the same for all the other special ones, which you could recognize by having the double underscores. So we're not going to have time to learn about all the special methods, although you might want to go ahead and learn more about them because they are quite useful. But we're going to just talk about a couple of different ones that will get you started on the ideas of what can be done with these. So printing in the special method stir. So notice that this is a double underscore and stir. I wonder if that has something to do with string. Well, in fact, it does. Excuse me. So stir is going to allow customization of what is printed when print is called. So remember that when we call print, it gives you some information that you may find less than intuitively helpful. By default, when an object is printed, information about where it is defined and its memory location is displayed. Well, great, but who needed to know that? Maybe that really wasn't very interesting or helpful to you, and maybe you wanted to do something else. So this behavior can be changed or customized by defining the stir method and customizing what information is displayed. So here's our default printing behavior. So for example, if you do print point, it's telling you that it's a class in main and that it's called dot point, right? Example of point class. And if we print point like this, notice that this has the parentheses here. We're going to get the information about where it is located on the disk. And so that is less than helpful. So what we might want to do is customize that. So let's customize the printing of the object. So what you need to do is you need to define the special method called string. So notice that we have the double underscores. It must return a string. So this is part of how it works. This is how it is. So typically it's set to report some info on the object, such as the value of the attributes. That's usually what somebody would choose to do. Could you choose to have it print out happy birthday? If you really want to, nobody's going to stop you from doing it. But that, of course, wouldn't be a helpful thing to do. So the point is, it has to be a string of any kind. You can customize it to whatever you want, but the expectation is you probably should customize it to report something about the value of the attributes. What it prints can be customized to whatever you want. As long as it's a string, the method will be executed whenever you print the object. And this can be incredibly useful for debugging because that's probably what you would use it for. So let's add, oh, we lost our double underscores at the left here. What we want to do is we want to add string to point. So let's take a look at what that would look like. So here we import math and we're going to have the class point. We have our initialization, which we've already seen. We have our distance method, which we've already seen. So what's new here is this function right here, the stir function. And notice that it has the self parameter again. So basically, whenever you have a method inside a class, you're going to need self so that it pertains to that particular instance of the point. Here we have string of, so see what I'm doing here is I'm making a string. Okay, so I'm going to say x equals string of self.x. So you see why we needed self. This is going to look up its own value of x and its own value of y. One thing that you should notice about this particular thing is that in order to do the string, you need to do it as the concatenation. When we've done printing in the past, you may have been using commas. So you might have print and then like open quote, the value of x is, and then you close the quote and then you put a comma and then you put the variable name. So you may be tempted to do that here as well. However, I will point out that that's not going to work and that you need to use concatenation here in order for it to work. Then you just return your string and that's it. You could in fact even just do this as all one line if you want to be really fancy about it. So you might just have return x equals, so if you just do return and then this right here, that will also work. So here's an example. Here is xy equals 0.1, 2. So this is an object xy of class point. And then if we're going to print this, then instead of getting that gibberish about dislocation, instead we're going to get out the values of x and y, which is useful because as your code progresses, perhaps those values are going to change and you want to debug it, or you think there's something and in fact there's something else. So it's very useful as you're tracing through your code and removing any problems. Okay, so this brings us to operator overloading. We've already seen operator overloading before. We talked about it initially, for example, using plus. So we saw that plus can add integers, that plus can add floats, and those are different. Plus is also overloaded for concatenation when we have strings. And we talked about how under the hood, Python actually has different code for each of those depending on the type that's being used. So this is now a closer look at that to see how that actually works out and why we sort of just took that for granted earlier in the course. So what happens is that we have these special functions like add double underscore, add double underscore, that's going to configure what happens when you use the plus for that particular class. So what happened before is that there was a class called string in Python that had double underscore, add double underscore, and somebody already wrote some code that caused those things to get concatenated together. And there's another double underscore, add double underscore in the class of ints that then will cause two integers to be added together in regular mathematics. So you can see why they would be different, because the definitions are in fact in different classes, and that's why they have different behavior. And that's why we said that they are overloaded, because it's the same operator, but it has different code. And now we're seeing where that different code appears. It appears in the different class definitions as methods, special methods to be more precise. So the activity of operators can be specified using the special methods, and this leads to overloading the operators because you might define it to do something different in each of the different classes that you define. The operators have their usual mathematical meaning, and the operator can have different meaning in the context of each of the classes that's defined. So consider adding in the context of a point. Let's define a point addition as adding the x components and y components at 2 points. Could you define it another way? Absolutely, and that's part of why there's overloading, because some other person could define point addition as adding the x and y values together. I mean, you could define it to be whatever you want. You could define it to be something that's not meaningful, like maybe it's x squared plus y squared. Not that that would be something recommended to do, but my point is that you could do it. So let's define a point addition as adding the x components and y components of 2 points. Include the special method add in the point object. The parameter will be self and another point. Addition of 2 points will use plus, and that will then become defined. So let's see how that would actually work. So here we are developing our class point to have some new information in here. Now notice that several of these things we've already discussed, so we won't talk about them again. Focus on this green box right here, which shows adding the add method, special method, into your class point. So here we have the definition and the double underscore, which this is going to then indicate this is another special method. So our third one, we have init string, and now we have add. And we're going to define it like this. Again, we're going to need self as the input is a parameter, which we always need so that we can access its own values. And then we're going to also have another point. So this is going to add x components and y components of the self and another point. So let's take a look at what this is going to return. So notice that this is returning, this is actually in fact a tuple, but you can just think of it as a list. It's returning one thing that contains 2 entries. So we're going to have self plus self.x, the x component of this point, and another point's value of x. So what exactly does this mean? Okay, so the input here is another point. So that means it has to get the type right. So you see why it's so important for us to be keeping track of the types. So that means that if it's another class point, we can assume that it has the attributes that are required for points. That is because all points have an x and a y. So then we can assume the other point also has an x and y. So here is another point, which is going to have the attributes x and y. So here is the attribute another point dot x, and the other point's y, another point dot y. So then our addition is going to be the current point, x value, plus the other point's x value, comma, the other is y, and our own y, and another's y right here. So that will give back then an x comma y value that is the sum of the x's, comma, the sum of the y's. So 2 instances of the class, so now point can be added using the plus operator. So notice the fact that this actually requires that you in fact define 2 points. It's not going to work if you've only defined 1 point. So in order to run this, what you need to do is put this in. So how I'd recommend you do it is update your Python script to have our whole new class as we have it over here, having all of the things that we've talked about so far. And then go ahead and execute that, which won't do anything because we don't have any calls here. So then over in main, you can do it interactively. So you can define a point j equals 0.1, 2, and k is a 0.3, 4. And then you can do j plus k. So notice that the x's have been summed and the y's have been summed, and it returned that back to you as 4, 6. So that's not the only special method we have. We also have a very equivalent one called sub, which, as you might guess, is going to do a subtraction. So this is a special method. Sorry, there's a little bit of a difference here between sub and minus. Let's double check. You need to do it as sub. So this is the correct one, underscore sub underscore. This is not right, minus, it should be sub. The special method sub works much like the special method for plus. So what you can do is you're going to define the special method sub, not minus, but for the point class, using the self points x coordinate minus the other points x coordinate, and the self point coordinates y minus the other points y coordinate. So basically you're going to do the same thing that we did with addition, but instead do it with subtraction. And then demonstrate its operation with the points j minus k, where j is 1, 2, and k is 3, 4. So why don't you go ahead and try to do that. Again, just make sure you use double underscore sub, not minus. That's not it. keyword is sub, and see how you can do with that. All right, so welcome back. Here is an example of how you could do the subtract. So very analogous to add. This is what it's going to look like. Basically, it is the same return statement, but instead of using the plus, we're now going to use the minus. So this is going to subtract the current points value of x minus the other points value of x, and the current points value of y minus another point of y. And so if we go over here, we can set up a point j and k, which I've done is 1, 2, and 3, 4. So as we had anticipated, what it's going to do is it's going to subtract the x values. So we're going to have 1 minus 3 is -2, which gives this one from this subtraction right here. And then 2 minus 4, which also happens to be -2, which is from this subtraction defined right here. And so in fact, we get -2, -2. And if we subtract in the other direction, we flip the sign and get a +2, So great, seems to be working. All right, so that brings us to our summary and conclusions from today's discussion. We talked about motivation as to why we would be interested in doing object-oriented programming. I gave you an overview of that and how classes are examples of user-defined objects. We learned how to define a class, and we learned how to add attributes to that class to basically be the variables that are associated with that class. Then we talked about how to add user-specified methods. For this, we learned how to write the distance function, and we put that into our program. Finally, we talked about a couple of different special methods. While there are many of them available in Python, we took the time to talk about a couple of them. We talked about initialization, we talked about addition, subtraction, and configuring of strings. So that gives you a basic introduction to how to do object-oriented programming. As I said before, there's much more that you could learn about OOP, and I hope that you will do that in your spare time or as you go on in your studies. But anyways, this should give you a solid foundation and should be helpful for you as you complete your lab and your homework. So looking ahead, you're going to have your object-oriented programming lab on Thursday. Because you should be focusing on your exam, you can have a little extra time to complete your homework. Also, we're going to have a check-in. So please upload your progress to Moodle. You need to be studying for your exam. And as stated before, we're going to have some kind of a take-home exam. So next week, you should be focused on the practice exam and preparing for your exam. And the following week, we will have our second midterm exam of the course. All right, hope you're all staying healthy. Hope you're all doing well, and signing off till next time. Bye-bye.